What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at a popular topic, the law of sines. There'll be a day 2 where we talk about the law of cosines, but today our main focus is to find the law of sines and be able to solve triangles with it. We're also going to be able to find some areas of triangles first. So before we get started, these are ways that you can find area of a triangle if you're only given two side lengths and that's not a right triangle and you're not giving the height, because normally on a normal triangle we can find height by doing 1/2 base times height, but in this case we won't see just the base and just the height. So ways we can do that: we can do half of BC times the sine of A, we can do half of AC times the sine of B, or we can do half of AB times the sine of C. Essentially, wherever your angle is given, so let's say we're given angle A, I can take the two adjacent sides. So in this case, this is the BC option. I can take BC's product, half of that, and times it by the sine of A, and that'll help me get the area. So we're going to try that here. So here I am given these two products. So according to this, notice that A is across from A, so this could technically be A, this will be lowercase b, and this will be lowercase c. But I would take half of BC and then the sine of A. Okay, so I'm just going to plug in those numbers. B is 17, C is 19, and then the sine of A is 135 degrees. Once I type all that in, I'm going to round to the nearest tenth. I'm going to get about 114.2. Okay, so see if you can try this one. Pause the video, maybe draw your triangle first. We have A, B, and C in upper cases, and then across from those letters are their lower cases. Label what you can, and then determine what the area is. All right, so we know the measure of angle B is 60, so I'm going to type that or write that there. And then A is 19, C is 14, so I'm just going to take 1/2 of A times C, 19 times 14, and then I'm going to take the sine of 60 degrees, and that'll give me my area of rounded 115.2. Okay. The next thing we're going to talk about is the law of sines. So the law of sines can be found by writing the following forms for triangle ABC. We're typically just going to stick with this form. Okay, so the sine of A over the sine of A, so A being your angle and then little a being your side length, is equal to the same ratio of sine of B over little b, which is also equal to the sine of C over little c. So essentially what we're going to do is we're going to use proportions to help us solve triangles here using the law of sines. So we have a lot to calculate, so make sure you've got your calculators ready. The first thing I'm going to do, it says solve the triangle and round your answers to the nearest tenth. What we want to check off first is to make sure I have whatever angle I have and whatever opposite length I have, that's the one that needs to start my proportion. So I have the sine of 51 available now over 18. Okay, then I look to see, well, what is something that I do have and something that's partially missing? I do have 17, which is across from C. So I know that I could find the sine of C over the length of 17. Okay, and then how I would start to solve this is I'm going to cross multiply. So I'm going to get 18 times sine of C is equal to 17 times sine of 51 degrees. Okay, then I need to solve for sine of C, so I'm just going to be dividing both sides by 18. I'm going to get sine of C is equal to 17 times the sine of 51 degrees divided by 18. Okay, since I do not know the angle measurement, in order to find C, I'm going to have to take the inverse of sine and then of whatever this decimal is. This is going to take you some time if you just have a simple scientific calculator. So here's what I'm going to type in. I'm going to do sine of 51 first, which is 0.7771, then times 17. I'm going to get 13.2114, and then divide that by 18. I'm going to get 0.73397, but then the inverse sine of that is going to give me 47.2 degrees rounded. So letter C is 47.2 degrees, which means I now have enough information to find letter B. So I'd take 47.2 and add it to 51, and then I just find the leftover amount from 180, and I'm going to get 81.8. So angle B is 81.8 degrees. Okay? That means I now have enough information to try to decide what is side B equal to. And I'm going to scribble this out for now, and we'll come back to it in a second, but I'm going to use my extra space here. So I'm still going to use my starting point of sine 51 degrees is equal over 18 is now equal to the sine of 81.8 degrees over what is B. Okay? Cross multiplying again. B times the sine of 51 is equal to 18 times the sine of 81.8. Okay? To solve for B, I'm just going to divide by sine of 51, so I'm going to get this, 18 times the sine of 81.8 divided by the sine of 51 will give me the letter B, and that'll be rounded once we calculate it to 22.9. So if you didn't get a chance to calculate this guy, make sure you're able to do that. Okay? What we're going to do is we are going to try this second example. So my second example is here. Maybe you try and pause the video here, and when you're done, click play. All right, things that I'm given. I am given the sine of 40 degrees matches 16. So the sine of 40 degrees will go as 16, and then is equal to, I'm given 13, and that's across from angle B. So the sine of B will be equal to 13. So there's my proportion. Start by cross multiplying. So we got 16 times the sine of B is equal to 13 times the sine of 40 degrees. Okay? To find sine of B, I'm going to divide by 16 to get that isolated first. So I have sine of B is equal to 13 times the sine of 40 degrees over 16. And then this is where I need to use my inverse because I don't know the degree measure. So B can be found by finding the inverse of sine of everything here. 13 times the sine of 40 degrees divided by 16. Okay? So what I'm doing is I'm going to type this into the calculator as 40 times sine times 13, then divide that by 16. I'm going to get 0.5222. Then I'm going to find the inverse of that for sine, and I'm going to get 31.5 rounded. So angle B is 31.5 rounded, and I'm going to go ahead and write that right here just so I can get a visual. Now I have enough information to get angle C, so 31.5 plus 40, and then subtracting that from 180, I'm left over with 108.5. Okay, the last thing I need to do is find out what little c is equal to. So again, starting with the same way, sine of A, which is 40 degrees, over 16 is equal to the sine of 108.5 over whatever c is. So I'm going to get c times the sine of 40 is equal to 16 times the sine of 108.5 degrees. Dividing both sides by sine to isolate that little c, so I get 16 times the sine of 108.5 degrees over sine of 40. All of these decimals, once I divide by sine of 40, is going to round to about 23.6. Okay? All right. Next, we're going to see a little different things. This is when we have angle side and then angle side angle. These two before were just looking at different things like side angle and side angle. I find these, though, that we're going to try a little bit easier. Again, I'm going to start with just the left side here. So, solving the same way, I'm starting with the sine of 85 degrees this time because I'm given both of those, and then the sine of 29 degrees over little a. Okay, there's C. So A times the sine of 85 is equal to 9 times the sine of 29. divide both sides by sine of 85 to get a isolated, so 9 times the sine of 29 over the sine of 85 gives me some crazy decimals, but those are going to round to about 4.4. So A is equal to 4.4. Then I want to find C. So I'm still going to start with the sine of 85 is over 9 is equal to, I don't know my angle for C, so I probably need to calculate that real quick. So 85 plus 29, and then minus that from 180, I'm going to get 66. There we go. So the sine of 66 over C. So C times the sine of 85 is equal to 9 times the sine of 66. Dividing both sides by sine of 85, I'm going to get C is equal to whatever 9 times the sine of 66 degrees divided everything by the sine of 85. C is equal to about 8.3. Okay? So I got all my things now taken care of. Now let's switch gears and talk about the one on the right here. Okay. The one on the right here, we've got no matching things, but I can quickly find out what angle A is to use sine of A over A. So 70 plus 81, and then subtract that from 180. I'm going to get angle A is 29 degrees. So the sine of 29 over 10 is equal to, let's do sine of B over B. Sine of B is 70. Whoopsies. All right, B times the sine of 29, so solving my proportion, is equal to 10 times the sine of 70. That's going to give me, isolating B, 10 times the sine of 70 degrees divided by the sine of 29 degrees will give me a rounded decimal of 19.4. Okay, and then starting off the same way, the sine of 29, these are my A's, over 10, is equal to the sine of 81 over C. Cross multiply, C times the sine of 29 degrees is equal to 10 times the sine of 81 degrees. Isolate C, I'll do that by multiplying 10 times the sine of 81 degrees all over sine of 29 degrees, and that's going to round it to about C of 20.4. All right, last little bit, just a word problem here, but using the same thing. A surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from north to south. So bridge wants to be here. Find length of the bridge. First, it might be helpful to find out what angle B is. So I'm going to do 71 plus 60, and then minus that from 180. I'm going to get 49 degrees, because what I can do now is take the sine of 49 over 150 meters and set that equal to the sine of 60, which is across from where the bridge goes. Okay, so C times the sine of 49 is equal to 150 times the sine of 60 degrees. Isolating C, I'm going to have 150 times the sine of 60 degrees over the sine of 49 degrees, and that's going to round down to, or round up, 172.1 meters. That looks weird. Decimals right there. Okay, that's going to conclude our video on the law of sines. Tune in for our next video to get the law of cosines, and then kind of put them all together. Hopefully this video helped you. If it did, give it a thumbs up, and we hope to see you next time to tune in for some more geometry. Have a great day.